Alright, this is going to be somewhat new, somewhat old. Forms of linear equations. This is our day 4 video on the different types of linear equations you'll see. We did talk about this a little bit with quick graphs on the last video. The format that you guys will see is y equals mx plus b, where m is the slope and b is the y-intercept. We also call this the starting point. Okay, point slope form. We didn't talk about this in the video, and we didn't graph any of these yet. We will graph them on I think day 6, just for extra practice. Point slope form is the form that you're actually going to be starting with most of the time. I know this one is not as familiar to you. You probably just solved for b with slope intercept form in when you took algebra in 8th or 7th grade. But point slope form is what you use this when you have a slope. Again, m is the slope, and a point, x1, comma, y1. That's your point. And you just plug it in, and then you're done. That's why point slope's kind of nice. If you have a slope and a point, just throw it in there. Standard form's the weird one, just because there's some rules for it. Ax plus by equals c. Now, I know on the problem with the notes yesterday, we made just a general standard form equation with the sweatshirts and t-shirts, but we didn't follow all the things that you'll have to do when you're just working with equations. With standard form, a, b, and c are all integers, no fractions, and a has to be positive. Okay, and we'll go through this as we go. So anyway, let's look at the first example. Here's what you got to do: write it in point slope form, then go to slope intercept form, and then finish it off in standard form. On your worksheet, you'll see this as PSF, you'll see this as SIF, and you'll just see this as SF. Okay. Now, a lot of you guys would probably just do slope intercept form first because that's how you were taught. And that's fine. Any way you get to it is fine, but you do have to know point slope form for this chapter, and it's actually nice because you start with it and then you can keep working with it. So, first thing we need to write it in point slope form. Okay, so part A, point slope form. I have points. I have 2 points. And the other thing that's nice about this, it doesn't matter which point you pick. But we do not have a slope. So the first thing we have to do is find our slope. Now, if you guys remember from my lesson before, I like to find my slope by doing the jump method. Again, you can do y2 minus y1 over x2 minus x1. My jumps are 3 and 5, so my slope is equal to 3/5. So there's my slope. So my final answer for part A then. So part A, I'm going to pick point, let's pick the easy one, why not? I'm going to pick 1, 2, and I'm going to use this slope. So here's how you do that. It's always the y minus the y value is 2 here, equal the slope, parentheses, x minus the x value, and in this case the x value is 1. Now obviously if they were negative numbers, then they would become pluses here. But the format, it's always the opposite sign of the point. So if it's 1 and 2, this will be a minus 1, minus 2. That is the answer. This is point slope form. We put in the slope and the point. We always start with that, always. The reason why is, to go to slope intercept form, all you have to do is solve this now for y. So let's do that over here on B. So I have y minus 2 is equal to, I'm going to distribute this one. Okay, and now just solve for y by adding 2, or 10/5 if you will. So you get y is equal to 3/5 x plus 7/5 when you add those together, negative 3/5 and 2. And now that is my answer for B. So do you see how, I know, like I said, you guys probably solved for B using the point and the slope before and plugging it into the y equals mx plus b formula. So now once you have point slope form, you can just solve. It does the same thing. Alright, once you get here, you're here. Alright, so that's the second part. That's part B. Now we need to get it into standard form. Well, to get it back into standard form, you got to move the x term over with the y term. So for C, the first step is I'm going to subtract the 3/5 x over. And then the last step is we can't have a negative number here and they can't have fractions. So I have to decide what I want to multiply this whole thing by. And if you guys notice, since there's 5's on the bottom, 5 would cancel those out. And I need to change the sign, so I'm going to multiply everything by a -5. Okay? So when I do that, you get the final answer of, these cancel, you get a positive 3x minus 5y equals -7. And that is the standard form. So we just took 2 points, found the slope, started in point slope form, distributed and solved for slope intercept form, moved it around back to standard form. Okay? So that is how you follow through and do all 3 parts of those. Now let's do number 2. Write the equation of the line in slope intercept form that contains the point 4, -2 and is parallel to that. Alright, so first things first. We have a point, we need a slope. This tells you the slope parallel to that line. What's true about parallel lines? The slopes are the same. So if my one line has a slope of 2/5, this line has a slope of 2/5. I need to use 2/5. Alright, and again, I know it says write it in slope intercept form, but I always start with point slope form. So I'm going to start with point slope form first. Y minus a -2 becomes a positive 2 is equal to the slope times x minus 4. That's point slope form. I distribute and solve. So I get y plus 2 is equal to 2/5 x minus 8/5. And now I'm going to subtract 2. And I get my answer is y is equal to 2/5 x minus 18/5. And there is my equation in slope intercept form of a line that is parallel to that one. Again, quick double check. A slope of 2/5, slope of 2/5 parallel. Okay, so let's keep going. Alright, contains the point -1, -5, and it's perpendicular to this. Alright, so remember, perpendicular means the slope is opposite reciprocal of each other's. So the only thing we have a problem with here is we don't know what the slope of this is yet, do we? Well, let's solve this and see what the slope is, just in case, well, we need to know what it is. So, and then I'm going to divide that by 4, divide that by 4. I don't care about this right now, because I'm only using this equation to get the slope. Okay, so you technically have to divide that by 4 too, but basically it comes down to the slope is -3/4 x. That's all I care about. Okay, and that you can say plus 30 if you want. Alright, so the slope of this line is 3/4 x. Negative. And I should just say it's -3/4. The x does not go with it. But I don't want that slope. I want a slope perpendicular. So now, once we have that, okay, I have to use a perpendicular slope for this new equation I'm coming up with. Well, if the slope of the one line is -3/4, the slope of my next line becomes 4/3. It's an opposite reciprocal. The slope perpendicular. So now I have my slope and my point. Again, start with point slope form. Y minus y1, well, it becomes a positive 5 is equal to my slope that I want to use. I want to use the perpendicular slope. X minus a -1 becomes positive 1. And there's point slope form. We just have to follow through to get it to slope intercept form now. Y plus 5 is equal to 4/3 x plus 4/3. Don't forget to distribute both things. Subtract 5 and you get y is equal to 4/3 x minus 11/3. And that is a line in slope intercept form that is perpendicular to that other line and contains the point -1, -5. Alright, so again, the key is if you need to get the slope from another line, get that line into slope intercept form and then figure out if you're taking the same slope or you're flipping it and changing it. Okay, so let's look at direct variation now. Direct variation is very similar to slope-intercept form because your slope is always constant. You always have the same slope on a line. So we have two variables, x and y, show direct variation, provided y equals kx and k is not equal to 0. K is called the constant. That's the key. It's always constant. And y is said to vary directly with x. So if I say I have an equation where y varies directly with x, you would say y equals kx. So you can write it, and the y-intercept is always at the origin. So that's the big difference. It's basically slope-intercept form with your intercept at 0. So y equals kx can also be rewritten as this. And this is important because if we have points, we can always see if this k value is constant. This formula here will tell you if you have direct variation. Okay, so let's find out an equation using these two following this data here. The variables x and y vary directly. Write an equation that relates the variables, then find y when x is 12 and find x when y is 10. Okay, so first off, I have these two values. I know that y equals kx because it's varying directly. I know what y and x are. 10 is equal to 16k. So k, if these vary directly, k is 10/16 or 5/8. Okay. Now, I have my k value. I can go back and write a generic formula. So here's my y equals kx. Now I'm going to say y equals 5/8 x. So it's basically slope-intercept form with a slope of 5/8 with an intercept of 0. Here's my new equation. Y equals 5/8 x. And then it says find y when x is 12 and find x when y is negative 10. Alright, let's start with the first part. When x is 12, y is equal to 5/8 times 12. So y would equal 7.5. So that's the first part. Second part, it says find x when y is negative 10. So I put a negative 10 in for y, and I say that's equal to 5/8 x. Remember, when you are at this point, a lot of you guys tend to divide by fractions. Don't do that. Let's just multiply by the reciprocal instead, which is what you're supposed to do. So you get negative 80 over 5. These cancel. So you get x is equal to negative 80 over 5, or that turns into negative 16. So that's how you do direct variation. Set it up, y equals kx, plug in the two values to find your k value, go back to the original, and then find out the other answers using your new equation. And finally, show if it has direct variation. Again, in order for it to have direct variation, it has to be k equals y over x. That always has to be the same thing for each set of data points. So, let's try this. We have the first points are 4, 4. So k is equal to 4 over 4, which is 1. So that's my 1 point. My next point is 3 and 8. So k is equal to 3 over 8. Okay, right away you guys should be able to see what's happening here. K is equal to 2 over 12 because it's y over x, which is 1/6. Always reduce. Always reduce. Simplify. And finally, k is equal to 1 over 16. Now, k is supposed to be constant every single data point. Is it constant? Hopefully you guys know that all four of these things are not the same. So, tell whether the data shows direct variation. No, it does not for this one. If so, write an equation. It doesn't, we don't have to do anything. Let's go to the last one. I get k is equal to, again, y over x. So we have 1 over negative 4 or negative 1/4. The second one I get k equals 2 over negative 8, which again simplifies to negative 1/4. You have to double check everything though. That is negative 1/4. And finally, k is equal to 4 over 16, negative 16. Again, negative 1/4. So, we have the value of negative 1/4 for k that's constant, which means we have direct variation. And the nice thing is you don't really have to plug anything in. Remember, the equation is y equals kx. We know what k is. It's always negative 1/4. So my formula is y is equal to negative 1/4 x. And that is the equation I need to come up with. Okay? So that is slope intercept form, point slope form, standard form, and then some direct variation thrown in. We will practice more of this. Again, you guys will get good at following through, starting with point slope, going to slope intercept, and then finishing off with standard.